A pleasant day to you, icons and lady icons. Welcome to the second module of our discussion for the subject Special Topics in Natural Science. And for this module, we are going to discuss the concept of electricity. Electricity will be discussed both on Module 2 and on Module 3. But before we proceed with our discussion, I would like to apologize first for any background noise that you're going to hear during this recording. During this very uncertain time in the time of pandemic, there are actually different unforeseen things that might happen, and obviously when it comes to the teaching learning process, this different background noise would be some of the different hurdles that we are going to surpass for you to understand the different lessons that I am going to discuss for your class. Now let's proceed. On the discussion of electricity, we're actually going to consider here the innate properties that is present on every single atoms and every single material that is present on Earth. And those are the different charges. It is either a positive or negatively charged particle that determines what will be their interaction with other materials. The different charges are also manifested on the atoms themselves, which are the electrons possessing negatively charged particles, while protons are possessing positively charged particles. What are the different reasons why there are different interactions that is happening between these different charges? We're actually going to discuss this in the concept of electric current, or the electricity that is in motion. Remember, electric current, it is electricity in motion, while electrostatics, just like what you had discussed during your junior high school sciences, it is now electricity at rest. Whenever we're talking about electric current, there are actually different variables that we are going to consider in this discussion. The first one, let's consider the concept of current itself. Now, current is the variable that is actually being represented by capital letter I, and the unit that we are using for current, it's SI unit, it is known as ampere. Okay? And ampere is represented by capital letter A. That is for current. Now, the second variable that we are going to consider for current, it is known as the charge. Just like the charge that I have mentioned earlier, either positive or negative. Now, the value of charge is actually being represented by small letter q. Then, the SI unit for charge is known as coulomb and represented by capital letter C. Then, the third variable that will be considered on electric current, it is time. And it is represented by small letter t, and our SI unit for time, it is equivalent to seconds, and it is represented by small letter s. So please take note that whenever we're going to answer different questions related to electric current, these different variables will be taken into consideration. Once again, we have current, we have charge, and time. Current represented by capital letter I, charge represented by small letter q, and time represented by small letter t. Units, for current, we have ampere, for charge, it is coulomb, then for time, it is second. Not hours, not minutes, but rather seconds. Okay? Now, before we proceed to answering different questions that is related to electric current, let's consider first here what are the different relationships of the variables that I have mentioned earlier. Now, if we are going to use the triangulation of formula, just like what we did when we discussed density, the different relationships of those units are the following. The first one, whenever we are talking about current or capital letter I, it is always equivalent to charge over time. So we can actually extract different formulas from this triangulation. The first one, we can conclude that current is equivalent to, once again, charge over time. Then, if we're going to consider now the concept of charge, it is equivalent to current multiply it by time. And lastly, if we are going to look for time, it is now equivalent to charge over current. Okay, so that is how we are going to manipulate the different formulas that you are going to encounter when it comes to answering different problems related to electric current. Let's start on the problem that is pressed on page number 5, letter A of your module. This problem states that the charge present in an electronic device is 35,000 coulomb. How much current will pass through a wire attached to this device within 30 seconds? Now, whenever we're going to answer different problems, once again from density onwards, we are now going to use here the GRESA method. If you can still remember, the GRESA method stands for the following: G for the given, R for the required, E for the equation, S for the solution, and A for the answer. Okay, so these are the different things that you should remember when it comes to answering different problems. Just like the case of sciences, it should always be a step-by-step process. And now let's identify what are the different given terms. According to the problem, the charge, which is represented by small letter q, is equivalent to 35,000 coulombs. And also, we can determine that the time in this problem is equivalent to 30 seconds. Now, what is required? Obviously, we can observe here that we are looking for the current that will pass through that wire. Then, the equation, going back on the triangulation of formula that we utilized, that current is equivalent to charge over time. Then, for the part of solution, current is equivalent to, what is the value of Q? It is 35,000 coulombs. Then, time, it is equivalent to 30 seconds. Then, do the math. After we computed for the value of current, we're actually going to arrive with 1,166.67 amperes. Remember that the unit that we are going to use for current, it is amperes, while charge, it is coulomb, while time, it is in seconds. Okay? So this is just how you're actually going to answer different problems that is related to electric current. Then, you can see the different sample problems that is stated on still page 5 of your module on letter B, both B.A and B.B. Then, on a separate sheet of paper, please answer the practice makes permanent questions that is stated on the page 5 of your module. Once again, do not forget to use GRESA method in answering these problems. The practice makes permanent for this part of your module will be submitted at the end of the discussion week, which will be on next Wednesday. Okay, you're going to submit your practice makes permanent, your worksheet when it comes to this part, and the worksheet that is represented or that is present for this module. Okay, do not forget that you're going to submit those works. Once again, practice makes permanent on page number 5. Please answer it. In the case of electric current, other than the different problems that we are actually going to encounter here, there are actually different types of current that is being used and being utilized in the different appliances that is present in our homes. Let's simply consider the following diagrams. Whenever we are talking about the presence of current, we are usually using here the representation known as a circuit. More discussions regarding the circuit will be present on module number 3. But for the meantime, I'm just going to show you some examples of a simple circuit that we are going to discuss related to the different currents that is being applied on different appliances at home. So now, in this simple circuit, this symbol represent battery. Then, attached to the battery are different wires. Then, we are going to use a resistor, or for instance, let's use a load. Whenever we are talking about a load, it is actually a type of device that converts electricity to other devices. This load could also be in the form of a bulb, a fluorescent light, a buzzer, or even a heater. Whenever we're talking about load, it is just any type of material that is possessing different types of ways on how electricity could be converted. Also, this load can be represented by these zigzag lines, and these zigzag lines actually represent resistance. And whenever we're talking about resistance, all materials present around us are actually possessing different types of resistance. Even our body, we're also possessing different types of resistance. Now, going back to the main topic, what are the different current that is being used on the different appliances at home? So there are actually different types, and we're going to focus on two major classifications. The first one, we have the presence of the conventional current and the electron current. Once again, we have the conventional current and electron current. Now, what is actually the difference between the two? Now, whenever we are talking about a circuit, could either be in the form of a plug or whether you are going to use a battery, it is actually possessing a positive terminal and a negative terminal. Or, whenever we're talking about the terminals, it is either the starting or the ending point of the current flow. Remember, whenever we're talking about current, this is just like the flow of water. It is just like the breeze of the air. It is always moving from one direction to another. In the case of a conventional current, as also stated on your notes, conventional current, it is the type of current that is when the electrons that is present here on your battery or from the electricity source is moving from the positive to the negative terminal. Once again, for conventional current, it is the type of electron flow that is moving from positive to negative terminal. Okay? Or CC is positive. Okay? Remember that. While, on the contrary, in the case of electron current, it is the other way around. It is now the movement of current that is coming from the negative end of the battery or of the electricity source towards the positive end, or EC is negative. Okay, once again, conventional current, it is positive, coming from the positive end of the battery to the negative end, while in the case of electron current, it is now the other way around, or vice versa. It would be from the negative side of the battery moving towards the positive side of the battery through a wire. Remember that the wire, it is just the connection that connects the positive and the negative part of your electricity source. So that is for the first type of current flow, the CC or the conventional current and EC or the electron current. What is the other type of current flow that we can actually observe on the different appliances on our home? It is now known as either the DC or the AC. In the case of the DC and the AC, this is actually being utilized on different types of electronic gadgets for them not to overheat. Electricity, they're actually possessing different types of tendency that they might overheat because of the presence of different electrical flow. Even the fluctuating electrical flow that is present in our homes can actually cause serious damages on different appliances. For instance, if a refrigerator is carrying too much electricity, there's a possibility that some of its wires will melt and will cause to house fire. Or in some cases, if your battery is overcharged on your cell phone, it actually might explode. Now, in the case of the DC and when it comes to the AC, these are actually the different types of current flow that is being utilized by different manufacturers for us to avoid those circumstances. Okay? Or simply, to put it into layman's term, ginagamit ito para maiwasan ng sunog. Kaya ito yung ginagamit ng iba't ibang mga manufacturers for us to avoid these different types of accidents. Okay? So, in the case of direct current flow, direct current or DC, from the name itself, it is just utilizing one single flow. It is a single flow of electricity. DC could either be an example of a CC or conventional current or EC. Remember, it will just flow on one single direction. Now, DC current are commonly used on different appliances, just like on our light bulb, just like on Christmas lights. Okay? That is actually one of the basic examples of the direct current. It is just moving on one single direction. Okay? It is not fluctuating. It is not changing. Now, in the case of AC or alternating current, from the name itself, it is now using alternate electron flow. For the first 30 seconds, for instance, it may go from positive to the negative portion of your circuit. Or the next 30 seconds, it will now move from negative to positive. From the name itself, it is alternating. Okay? It is not only following a single direction. AC, it is on two directions. Okay? It is following two different directions. It could either, once again, it could be moving from CC or conventional current from positive to negative, or electron current from negative to positive. Now, why is alternating current one of the most common type of current flow that is being utilized on different appliances? First and foremost, it will not cause overheating of different appliances. For instance, majority of our laptop or on our electrical devices, they're actually using alternate current because not all the times that the battery will be overused. It will actually avoid the presence of overheating. Whenever there is alternating current, the charge flows not on a specific direction, so it means that the wire can actually rest for it not to overheat. Because if overheating of different appliances will happen, definitely our house fire will be very common. So remember, whenever we're talking about the current flow, it is just simply to avoid different types of accidents.